Last time we did the equation of a circle and its tangents. This is the page we ended up with. Very briefly, we know that in GCSE maths, all circles are centered on the origin. So we get a nice simple equation for the circle, x squared plus y squared equals 5 squared in this case, which means the circle goes through 5 and 5 and minus 5 and minus 5. That's all straightforward. That's nice and easy. Those circles are always nice and simple in GCSE maths. When we're looking for a tangent to a circle, they're going to tell us a point it goes through. And based upon that point, we know a tangent is perpendicular to the radius. So we can work out the gradient of the radius from these values, the gradient of the tangent by using m prime equals minus 1. And then we can go on to work out what the equation of the tangent is. So that's all quite simple. That's straightforward. That's the sort of thing that's not going to be worth very many points in your GCSE. It's the sort of question that's going to appear somewhere around the middle of the paper, probably. Today we'll do some harder equation of a circle and tangents, so the sort of thing that appears at the very end of the paper. Here's that sort of question. So the equation of a circle and its tangents, and these are harder. Find equations of both tangents to circle x squared plus y squared equals 45 that are parallel to 2x plus y equals 4. That looks difficult. So let's draw a very quick picture. X squared plus y squared equals 45. So what the radius is root 45, which is a bit less than 7. So we've got a circle. With a radius that's a bit less than 7. That's circle-ish. I'll just write it as being root 45 and root 45 minus root 45 minus root 45. That's 0. That's y. That's x. Now I've got this line, 2x plus y equals 4. Usually when you're drawing a line, you want the line in the form y equals mx plus c. So let's rearrange it. Y equals minus 2x plus 4. That's the line with gradient of minus 2 that goes through the point 4. We know here it's just less than 7. So let's make 4 about here. Gradient of minus 2, so it goes downwards quite steeply. So we'll label that y equals minus 2x plus 4. Now the problem just got easier. We want the tangents that are parallel to that line. Well, the tangents parallel to that line are going to be one about here. So we'll call that one T1. And we'll say it touches the circle at A. And one about here, which we'll call T2. And we'll say it touches the circle at B. We already know what the gradient of these lines are, because they're parallel to this one. So T1 and T2 have gradients -2. Okay, we'll draw a radius to A. R is the radius, is such that y equals m prime x plus c, where m prime equals minus 1. I haven't called this m, so let's call that equals m, where m prime equals minus 1. That implies that minus 2 m prime equals minus 1. A very quick bit of rearranging tells me that m prime equals a half. So r is such that y equals a half x plus c, but also r passes through origin. Zero, 0. So r is such that y equals a half x. So now I've got an equation that tells me that y equals a half x, and at A and at B, x squared plus y squared equals 45. So at A and B, let's substitute for y in there. X squared plus, well, y is a half x squared equals 45. That means that x squared plus a quarter x squared equals 45. That's 4 quarters plus 1 quarter, 5 quarters. X squared equals 45. Rearrange. X squared equals 45 times 4, divide by 5. 45 over 5 is 9. 9 times 4, 36. At A and B, x equals 6 or minus 6. Now we can see from our diagram that A must be 6 and B must be minus 6. So at A, x equals 6, or y equals a half x. Y equals 3. And the equation of the tangent T1 is such that y equals, we said T1 has gradient m, and we'll call this K1 as our constant. We know y is 3 equals, we know m is minus 2 times x, which we know is 6, plus K1. Minus 2 times 6, minus 12. So 3 plus 12 equals 15 equals K1. That is, T1 is such that y equals minus 2x plus 15. Let's repeat for B. At B, x equals minus 6, y equals minus 3. T1 is such that, sorry, T2, apologies, is such that y equals mx plus, and we'll call this K2. We've got the value of y, negative 3 equals m, which was negative 2, times x, which is negative 6, plus K2, minus 3, that's minus 2 times minus 6 is 12, minus 3 minus 12, that's minus 15, or negative 15, equals K2. So at B, T2 is such that y equals negative 2x minus 15. So the question asked me to find the equations of both tangents to circle x squared plus y squared equals 45 that are parallel to 2x plus y equals 4. Those are my two solutions. I think I'm going to give myself full marks.